Welcome to this webinar organised by the Process Industries Division of the Institution of Mechanical Engineers, IMechE, in collaboration with the International Fugitive Emissions Abatement Association, also known as IFEAA. And IFEAA is a not-for-profit organisation working to accelerate action to reduce fugitive greenhouse gas emissions. My name is Dr. Tim Fox, and it's my pleasure to be chairing this event today. For those of you that don't know the IMechE, it was established by George Stephenson in 1847 and is the UK's professional body for mechanical engineers, with around 115,000 members, many of those based overseas, working either in companies that have sent employees overseas, or indeed members from within the populations of those countries themselves. The primary role of the institution is to confer chartered and incorporated status to suitably qualified and experienced engineers, to deliver lifelong learning programs and skills development support, of which this webinar is a good example, and to provide opportunities for members to meet, exchange ideas, and to innovate. Next slide, please. The webinar will involve 3 short 10-minute presentations, followed by a 20-minute Q&A session, which I strongly encourage you to participate in by placing your questions using the Q&A function as we go through the next hour. Please, however, do be aware that the event is being recorded and it will be posted on the IMechE's webinar hub in a few days from now. To aid the smooth running of the event, all attendee media has been disabled. The slides will be made available at the discretion of the presenters after the webinar. Next slide, please. So we have an excellent lineup of speakers, and I should say at the outset that John Phillips, whose picture you see within that list of participants, is a member of the IMechE's Process Industries Community Hub, and was the principal liaison between the IMechE and IFEAA in setting up this webinar. So thanks very much to John for actually making this happen. I'm going to introduce each of the speakers as we go along. So if I could have the next slide, please, Murad. Thank you. As many of you will be aware, and probably partly that's the reason why you've joined this webinar, agriculture is currently the UK's largest emitter of methane to the atmosphere, with livestock as the primary contributor. Emissions of this potent greenhouse gas from manure can be avoided using anaerobic digestion, commonly known as AD, or more recently through capture from slurry lagoons to provide renewable fuel, which can be used on farm to power tractors and generators or sold for use off the farm. This approach brings benefits for farmers by reducing fuel costs and providing additional income from fuel sales, alongside the environmental benefits of mitigating global warming and reducing air quality degradation. This webinar is going to explore the rationale behind on-farm methane capture and AD, share new technologies on the market to do this, and consider actions that are needed to accelerate the uptake of these approaches. Our first speaker is Professor Penny Atkins, who is the Chief Executive Officer of IFEAA. Penny is a mechanical engineer with a background in sustainable energy technology strategy and product development, which was gained in roles including the head of technology strategy at Ricardo and director of the Advanced Engineering Centre at the University of Brighton. Penny is currently a visiting professor of sustainable energy at Brighton. Over to you, Penny. Next slide.
Thanks, Tim. Yes, as Tim says, I'm going to provide some background really around why you might want to do anaerobic digestion or methane capture on farm, before we hear more from our other speakers around the technology that you need to do that. So as Tim has already said, IFEAA is a not-for-profit association that aims to promote action to reduce fugitive greenhouse gas emissions, particularly methane. And you can see some of our supporters here, including IMechE. Some of the work that I'll talk about today we've been doing as part of a project which has been funded by Cornwall Council called the Net Zero Methane Hub, which is aiming to help build the market for biomethane in Cornwall. Next slide, please. So as Tim has already said, we know that methane is a powerful global warming gas, and also the main source of it in the UK now is from agriculture and particularly livestock. So two sources of emissions here: enteric emissions from the animal itself, and then emissions from manure management. Next slide. So if we're going to work to abate these emissions, it's very useful for us to understand how much methane is coming from which source, so we know really where we need to focus our effort. So it's useful to start with just to think about how we might actually understand that. Now, there are different ways of measuring methane from sources like manure on farms or perhaps water processing plants. So if we think about the range of processes that are available, a lot of these have come from oil and gas. So if we look at optical gas imaging, so this is the image on the top, you can see that this gives us a very visual representation of methane emissions, which could tell us a lot about, for example, where methane is leaking from plant, but it's actually difficult for diffuse sources like slurry lagoons, which is one of the major sources within agriculture, to actually understand how much methane is being emitted from those sources. So other techniques are in use at the moment. So on the left-hand side of the slide, you'll see a graphic which is illustrating techniques where you can drive through the methane plume to measure the emissions downwind of a source, and then use techniques like modelling the dispersion of that plume to understand what it might be. You can use laser analysis, and also if you use an isotope analysis of the methane from those sources, you can start to understand exactly what the sources are. So you can differentiate between enteric emissions and manure emissions. So there are ways of measuring, but I'll say that none of these are straightforward. So if we go on to the next slide, we'll see that often to understand national emissions, we use techniques based on an IPCC inventory. So this is the kind of method that we'll use to understand nationally what the methane emissions are from different sources. So if we're looking at methane in agriculture, particularly from dairy, there are different levels of complexity of assessment. So we can use a tier 1 assessment, which is based on simply the number of animals and the ambient temperature. We can use tier 2, which uses much more complex data around, for instance, what type of animal they are, how long they're housed for. And this is the technique that the UK uses currently. Or we can use tier 3, which does incorporate some of those measurement techniques. Now, IFEAA has been doing some work recently, which we'll see on the next slide, which is actually to measure directly methane emissions from farms. So in actual fact, this is using, rather than measuring a methane plume downwind once a quarter, for instance, this is using data on methane that's captured by a cover, like the one you'll see later from Veneman, to understand what the methane emissions were throughout the year. And what you'll see on this slide is the yellow line on these two graphs is the methane emissions from two different farms, and then plotted against some other variables which are significant in terms of what those emissions might be. So the light blue line is ambient temperature. The dark blue line is the slurry coming in and out of the slurry lagoon. And on the right-hand plot, you'll see we've also plotted rain. And what's interesting to note here is that firstly, we have quite high average levels, so around 150 kilograms per animal per year. And also, it doesn't correlate particularly well with some of the variables that you might think it would. For instance, air temperature in this kind of slurry lagoon, which is effectively a lagoon in the ground, doesn't particularly correlate with methane emissions. But I think the most important conclusion from this slide is that at 150 kilograms per head per year, this is a significant amount of methane to be emitted. So for the project we've been doing, the Net Zero Methane Hub within Cornwall, we made an assessment of what methane emissions could be across the dairy herd in Cornwall, including also emissions from beef cattle and human waste as well. That could be as much as a third of the natural gas consumption within the region. So in other words, it's a very significant amount of methane. So if we look at the next slide, we'll see that the good thing about methane in terms of a greenhouse gas emission is that we know that we can capture it. So there are two methods which Tim has mentioned. We can use anaerobic digestion at various scales, from really very large, where we're it's an industrial plant where we're then injecting gas into the gas grid, down to much smaller plant that we'll see this afternoon, which is an on-farm plant, which you could use to generate electricity or fuel on farm. Or you could use a technique where you simply capture the methane from a slurry lagoon and then use it in a similar way. Now, as I say, the good thing about this is we're actually making a renewable fuel. And what we know is that if we capture and use methane, then we can give significant benefits in terms of CO2 emissions. So the graph here shows CO2 emissions, a greenhouse gas emissions intensity for a truck using different types of fuel. So the bottom green bar is fossil fuel comparator, so diesel, and above that then are various different types of renewable fuel. And you'll see that if you look at biomethane, which is the third one down, then you're getting effectively negative emissions, because you're preventing the emissions of methane and their global warming effect and then replacing the fossil fuel. So in other words, methane is a problem, but it's a good thing in terms of, it's not a good thing, but we can capture it and use it to replace fossil fuels. So if we go on to the next slide, we'll see that the issue here is actually, although we know we can deal with manure to give us reduced emissions and a renewable fuel, in actual fact, we're not doing it. So this graph shows feedstock use for anaerobic digestion versus availability from, this is a lovely diagram from NNFCC. And you'll see that although we're doing quite well on food waste, for example, using about half of it, in fact, for livestock waste, it's less than 3%. So if we go on to the next slide, we started to think about why this might be. So in actual fact, the average dairy farm in the UK is around 180 head of cows, so relatively small farm. It's not the kind of large farm you might see in California, for example. Also, if you're thinking about perhaps using a large anaerobic digester and transporting the slurry to it, slurry has a very high water content. It's mainly water, so you're using an awful lot of energy to transport that slurry to the anaerobic digester. And if you want to site a large anaerobic digester in a rural region, often you have poor gas grid coverage. So the graph in the middle, the green regions show where you have high density of dairy farms. So you'll see the southwest, where we've been working, has significant proportion of the UK's dairy farms. And then the graph on the far right then shows the percentage of homes off the gas grid. So in other words, how well served is that region by the gas grid. So you'll see that the southwest, around 50% of homes are off grid. So the number of choices for sites where you might have good access to the gas grid is relatively smaller. And also you have the rural road system to contend with. So the image I've included on the bottom left here is of a coach that got stuck on what is really a typical Cornish road, because they hadn't planned their route carefully and literally had to be there all night. So in other words, it's difficult to move large vehicles around in the roads here, and not good for the residents. So you might start to question whether transporting manure to central digesters is useful. And in fact, is it much better to be doing on-farm anaerobic digestion or methane capture? And if we look on the next slide, we'll see that not only does that give benefits in terms of the local environment, it can also support farmers in terms of providing energy independence for them, so they're making their own energy from the manure, and also some other environmental benefits. So the life cycle here you can see is that the livestock eat the grass, then you can digest the manure within either a covered lagoon or an anaerobic digestion plant, harvesting that biogas and clean that up to produce power in a gen set, or if you process it more to give biomethane, when you remove the CO2, you can potentially even fuel the tractors. So CNH have recently released a methane powered tractor. Now, there are wider benefits in terms of the residue that comes from the anaerobic digestion or the lagoon can then be spread, replacing chemical fertilizers to grow the grass that the cows then eat. So you have this very nice circular economy within the farm. And if we look at the next slide, we'll see that this does make financial sense. So the blobs on this chart are showing the range of payback times versus the size of the farm. So the y-axis is showing payback time in years against the number of cows that are on that farm. So you'll see that the payback times vary from somewhat reasonably high, around 10 years, but down to 5 years for larger farms. So in other words, it's commercially viable to do this kind of approach. I think what's important to note here is that the average dairy farm at around 180 cows does give you relatively longer payback times. So if you want to gain maximum benefits, in other words, maximum emissions reduction nationally and for farmers, it's useful to support upfront investment to help reduce that payback time, but more later. So that's the end of my presentation now, and we'll hand over to Benjamin to hear more about the technology.
Thank you very much, Penny. That was an excellent overview of the methane capture landscape. Thank you. Our next speaker is indeed from Benjamin Limited, who are the developers of technology to enable you to capture the methane from slurry lagoons on farm and process it into fuel. And our speaker from Benjamin today is Edward Humber, their business development manager. I should say that Edward had to step in at the last minute this morning to make the presentation because Dr. Chris Mann unfortunately has gone down with an illness. So over to you, Edward. Could you please just say a few words of introduction to yourself before setting off on the slides?
Brilliant, thank you, Tim. So, hi everyone. Hope you can hear me. So, yes, I'm afraid you've drawn the short straw, and you've got myself and not Dr. Chris Mann. But hopefully, we can give you a good intro and a good overview of what we do at Benjamin. So, I joined Benjamin last April as part of a big intake of people following some changes in the company, which I'll cover in the presentation. So I'm business development manager to start with, which was covering fugitive methane off of slurry lagoons, and then I've merged into our anaerobic digestion offering, and varied background. So electrical engineer originally, then 11 years of agricultural and land-based policy with the National Farmers Union, and then into Benjamin last April. So technical understanding and know-how, and also the impactful part of environmental regulation and greenhouse gas emissions for farms. So made it kind of ties it all up very nicely. Can I have the next slide, please? So quick intro. Dr. Chris Mann founded Benjamin in 2012 with the view that ultimately conversation around fugitive methane that he had with somebody whilst in America, and they were getting fugitive methane explosions within people's garages off of bags of grass clippings that had got warm in the sun. And Chris brought that idea back and thought, hang on a minute, the one sector that's really being persecuted at the moment is agriculture, and wouldn't it be nice if they could fuel and run their own farms off of their fugitive methane? So he started on his journey. He founded the business, brought in some assistance through various different sides of engineers and technical advanced people to help with the development of the product, and got it to a stage where we have sort of 5 or 6 sites operational in Cornwall that we're running on our option 1 technology. They were an R&D capture type site scenario, and at that point Chris was approached by CNH through Case New Holland Industrial to become a major investment shareholder within the business. So that happened in 2023, and it's encouraged Benjamin to push forward, and it's enabled us to be in a position where our technology is advanced and it's out on the ground, and also we've got an international program now to internationalize our products and get them out and about. So our solution, essentially what we do is we harness farm lagoons and AD plants, latent potential, and upgrade biogas for biomethane. So it could be raw biogas going through generators, but it's also we have biomethane upgrading kit. And our aim is to get the farms to better than net zero green gas and better net zero situation with their carbon footprinting. Our big thank you. Big purpose we want to do is try to make farms more economic, as well as reduce the environmental burden and the risks of farmers being exposed to emissions regulation, which is coming down the road. So could you just there should be 4 drop downs. If you keep clicking on, please. All right, there you go. One more, that's it. So when I talked about our option 1, so we've deployed on a number of farms in partnership with Cornwall County Council. And as a result, we took Cornwall County Council farms, installed a lagoon, which would be, I suppose, as close to a cold AD site as potentially possible. It is a insulated lagoon, but there is no heating that's within it. And on top, we have a blown or a domed cover, which is moving to a blown version as we speak. Ultimately, the result in this has been a massive benefit to the farmer. So their net zero CO2 emissions has dropped. So from 734 tons per CO2 per annum down to minus 64 tons CO2 per annum. And that's not just our part. I must stress there are other things around environmental obligations the farmers done around hedgerow management, around field management, around changes of practice. So it's a combined effort, but it does prove that the journey to reduce emissions is viable and available to farmers should they cover their lagoons. Operational cost savings and stability with a net benefit of £47,000 per year, and that came from electricity, diesel offset, fertilizer offset, and spreading reduction. So A, we take the rainwater out. B, we have enhanced slurry that has got higher ammonium content because it's not being moved away by wind that's been passing over the slurry stores. And then we have the harnessed part where we take the energy through the fugitive methane gas and we convert that into a biofuel, so a gas to run generators, or a gas that could be upgraded to biomethane. We've seen increased soil regeneration as well, so the improved grass quality and concentration and worm density, partly because the digestate is more concentrated. So we've not got the volume of water. The slurry coming out the back end is enhanced, and it's more widely taken up by the plants that are growing. So actually, it's a real benefit from both sides of that argument. So one, it's reducing your reliance on fossil fuels and other aspects of the business, and secondly, it's about improving your soil quality. And the big aim, the big driver is that, you know, Chris and others looked at it and went, well, we want to keep eating meat and we want to keep drinking milk. And the big thing there is to try and have a carbon-free milk as much as possible. So with the hope that the market one day will pay for that, but also more than anything, it means the market is not going to be against farming like it can be in certain situations now. Can we move on, please? So essentially, it all starts with a smart cover. And this is, I've kind of left this as a wide overview. So this is an example of a site that's up and running. It's actually at a farm right near the Royal Cornwall Showground down in Cornwall. And I just wanted to give you the overview. So if we start on the left-hand side, we've got what's called our terra stores, and they are a gas capture bag. So following the gas has been caught in the lagoon cover, it's stored in those bags. The lagoon cover, the big rectangle in the middle with the light green colour, that is our lagoon covering technology. So it operates on a system where we've got a skirt around the outside that's dug into the walls of the lagoon. We have a floating skirt on that runs out to each individual tile. So you'll see there what looks like square profile shapes, and each one of those tiles is the gas capturing system for that lagoon. Series of pipes that connect them up, and then the gas is brought back through to a filtration system, and then the filtration system allows it to be put through our biocycle and upgraded to biomethane, or should there be an overload or some reason we can't process, then you will also see that there's a flare there that's required as part of the environmental permitting laws. It's a really neat system, works really well, and we have some dynamics within the cover. So we have water ballast tubes and air ballast tubes that work in positive and negative pressure against each other to keep the lagoon cover down onto the lagoon. It also means that you can hit, more than 100-mile-an-hour wind speeds quite comfortably, and this thing will not move. So each tile weighs a couple of ton in weight, and therefore we've got the ability that it just stays on the surface of the lagoon. It also helps us stop the forming of crusts and tries to keep the lagoon as much as possible in a more fluid and more homogenized state, so that we don't have icebergs or lumps in there. A big win for Benneman was that we actually managed to get through lobbying with the government that we could be eligible within their SIG funding grant, which came out last year. So that's enabled farmers to be able to apply for slurry infrastructure grant funding and get a award towards the purchasing of the kit. I mean, it's an expensive thing to do. We have to meet gas processing regulations, because that's what we intend to be doing on the site. Therefore, you've got the enhanced fencing around the outside, you've got the nice stoned areas, and we've got ATEX zones and stuff to work within our compounds. So it is over and above what a normal farmer would do for slurry system management and diverting of rainwater. But ultimately, a standard slurry cover provides no benefit other than to stop rainwater and potentially reduce some emission offset. So whereas we can provide them the solution to harvest their biogas from fugitive methane and turn it into a readily available product that's got a sale value and a real value to the business. Can we move on, please? So I thought I'd put this up about the ecosystem. I mean, Penny's actually covered this really, so we won't stop for very long on it. But essentially, the cows form the slurry. We capture the gas under lagoon covers. We can do two things. We can either process the raw biogas, or we can take the raw biogas and actually run it through a sour gas generator. So at that point, on a smaller farm, they could run a small-scale generator, sort of up to about 30 kilowatts, which we matched to a battery storage system and a small set of solar panels, so we can take in peak demand electricity demand on farms. So that can be done as a small system for smaller farming units. And then as you get bigger, then the opportunity for the gas and the amount of volume of gas that you have widens your market. So we then look at a gas filtration system, which is our gas filtration system operates with carbon drums. So we have carbon filtration to remove the hydrogen sulfide, which is obviously the very harmful agent within slurry gas that can cause fatalities to people, but also it's highly corrosive, and you really don't want it anywhere near any of your tech. So we clean the biogas, and then the biogas goes into our mobile methane upgraders. So part of this journey with Benneman was that they designed a methane upgrader that allowed us to go around to the slurry lagoons and harvest small volumes of biogas that would be stored in those terra stores that I mentioned on the last slide, in the big green square pillows, and we could harvest a day's worth of upgrading, sort of, that would make us about 400 kilos of biomethane a week. And we can go around to the farms, we can do this for them. So rather than them owning one big piece of kit each, we can go around and do mobile processing. And it's worked really well from that perspective, and we've been operating that system for many years. And as a result, we have Cormac, which is one of the companies within Cornwall Council that do their highway maintenance, and Cormac have lorries running off of this gas. We then compress it, so our methane upgrader has final compression, and that takes it to 250 bar, which would be formerly known as CNG fuel, and then we use that fuel in whatever way the farmer wishes to. So it could be that they're going to fuel generators, it could be they're going to fuel tractors, or it could be lorries. And then off the very back end, underneath the cover, as and when farmers are required to remove volume from their lagoon, then there's a highly enhanced slurry that goes out the back door in the same way that digestate would in AD. Can we move on, please? Keep going. Let's just click through. So this is the system in its way. Could we go back one slide? Right. Yeah. So as I talked through it, so top right was the covers. That next one down is the GFS system, and the bottom right is our terra stores. So they would be inflated. They hold about 500 cubes of raw biogas each. Bottom left is the biocycle, so that's it in processing state. So essentially, it's made to be plug and play. It's mobile. It's connected by flexible hoses and dry couplers, and it has a very small electricity need. That's one of the biomethane generators, and then up the top is the example of a tractor being refueled directly off our device. Yeah, please move on now. I mentioned that our system is there for upgrading biomethane, or biogas to biomethane. An offshoot that we've actually noticed and are now exploring this market and moving into this field with devices out in the market already is that our biocycle also provides a significant opportunity for anaerobic digestion sites. So a number of farms have these just simply because it helps with slurry management. It can create them an energy source. They've got thermal heat for items that they need within farming, and also it's an economic return. You know, they've got a feed-in tariff or an RHI or some other supported tariff from government, which means this thing actually pays. So they have to manage their slurry anyway. So they've invested in significant amount of money to put their digesters in and actually make their plant operate. And the offshoot for us is that they usually have an abundance of biogas. So quite a lot of these digesters and systems within AD have been designed at a level that's actually them ticking over in reality. So they could be hemmed in by a number of things. It could be that they might have a very small electricity generation tariff, or they might have a small output gas to grid tariff, but actually the digesters will have at least 25% capacity worked into them to allow for an increase to build more gas. Within that gas that they've got there, then we also have the opportunity with our biocycle to upgrade that gas to make it into road fuel in larger volumes. It would be a static device, so the device sits there on their site. And essentially what we do is we need secondary filtration on their H2S. We want to get the H2S levels down below 3 parts per million. Our device will cut out at 3 parts per million. It's really simple connection, 2-inch flow, 1-inch return. And ultimately what we end up with is a biomethane supply of 140,000 kilos a year, which that could then be coupled to storage for cascade refueling for the farm, or for them to sell on as they wish. Can we move on, please, Mark? The upgrading component. So our upgrader is essentially a miniaturized upgrading system that you would already see on an anaerobic digestion site. So it is a portable skid, so similar size to a 20-foot shipping container, has the flexible plug and play connections, and it weighs just over 3 tonnes, and that allows it to be picked up and moved around by larger forklifts on sites. And the beauty of ours is it has a small input requirement of 55 cubic meters an hour of biogas. We can stack them in parallel. So if people have more gas, then we can actually run our devices to take up that extra gas. If they found their gas profile dropped for a few days, they could turn off one device and then just operate on the other. So we have the flexibility to meet the supply and demand, both from gas supply and fueling demand of a company with the scale of our devices. So as I said, it's like a miniature upgrading system that you'd see on a grid entry unit. So we have initial compression, we have cooling, and we have membrane separation for selective removal of the CO2. We then have some high pressure drying and filtration to remove contaminants. We can have odorization. You know, suggested it's ideal, is recommended for use in vehicles with odorization, but whereas if you were putting it into the grid, they wouldn't want odorization because that's done at the final stage. And we also offer final compression for storage and distribution. It is a small device. It needs an input of 3.5 bars pressure, 55 to 60 meters cubed an hour, and a methane content of ideally somewhere around 55% CH4. We can work at a much wider range than that. We've just pitched on the middle of the range, really. We've got a device on farm currently. It's at 52% methane input, and we are at 98% methane output. And it is going to cover about 137,000 kilos of biomethane a year at that rate. Essentially, what it does is if the methane content is lower, then it takes longer through the filtration system, through the membranes.
Ed, we're going to have to start wrapping up, if that's okay.
Yeah, real quick. So just wanted to provide an example of what that means for people, because the cost analysis of this, it's not a cheap thing to do. Farmers could run 10 tractors off one device. They could run 10 small tractors, 5 large tractors. They could have 6 like row sort of dust cart type lorries, 4 big Arctics, or you could mix and match as you wish. Gas storage is the biggest thing. People talk about storing it, but if you have 900 of our bundles, so there's 16 gas cylinders in a TPED regulated bundle, 900 of them stacked up is a massive thing and a massive cost. Each bundle is about £6,000 to £7,000. So you can't really realistically do it. You need an in-time process to get rid of the gas, and that's partly what we also help and offer as a service. I believe, Marit, that's it. Thank you.
Thank you very much, Ed. That was excellent. Thank you. And thank you for stepping in for Chris at such a short notice. Our next speaker is Joseph Fail. Joseph is UK and Ireland country manager at Bioelectric. He has a double MSc in agriculture, food industry processes, and advanced chemical engineering. So we've had an electrical engineer, chemical engineer, and a mechanical engineer. We're doing well. He has experience in academic research into on-farm AD and has worked at Bioelectric for 2.5 years. Joseph has always been interested in new technologies, innovation, and helping the farming sector to grow and diversify. So enabling small on-farm AD in the UK made perfect sense to him. Bioelectric has been working on these systems for the past 15 years and has 400 plants running in Europe, with 2 new ones being installed each week. Just a reminder, if you have any questions to Ed, Penny, or Joseph, do put them in the Q&A and we'll get to them at the end of Joseph's presentation. Joseph, you've got 10 minutes. Over to you.
Thank you, Tim. Good afternoon, everyone. I'll try to stick to the 10 minutes. So indeed, Joseph for Bioelectric. Maybe to start, a few words from the company. If you can keep pushing, please. So Bioelectric, we're working on small-scale systems since 2010. We're a Belgian company based next to Antwerp. And we're probably the leader or the leading company in such system in Europe and worldwide. So we design small-scale system using only the slurry from the farm to generate electricity and heat, mainly suited for dairy farms. And the system comes as semi-modular, installed on the farm in a couple days with relatively low maintenance and high efficiency, and enabling the farmer to keep being farmers, but at the same time offsetting their emissions and electricity usage on the farm. So our vision is to give the possibilities for the farmers to have access to such technologies, to be more resilient and future-proof for their farm, making them producing their own electricity, but also heat, which can be used on the farm. Next slide, please. So as said by team, we're gradually rolling out the system across Europe. We last week had our 400 running plant started in Flanders. But we built around 450 plus. The others are to be commissioned or to be finished. In the background, you'll see the production facility working a bit like a car industry system. And we produce at the moment 2 new systems per week, where we can upsize the production to 7s a week on day shift only. In the UK, we'll have 22 running installation. And obviously, over 15 years, oh, you can go on the next slide, sorry. Over 15 years, we changed the system. So we're now on our 4th iteration of the design. So we started in 2010 with a bag system, where we changed into the final design, which is a stainless steel digester coupled to a container. We are now able to have a freeze version, and any new innovation we're implementing can be added into the same system. So as well for the older plants, we can retrofit them so they are as efficient as the new one coming nowadays. Next slide. So the product itself, so modular, the system will only come with a 20-foot container housing the electrics, pumps, heating system, and engines. And coupled to it, we'll have a stainless steel reactor, which, depending on the amount of slurry used and power output, several sizes will be available. So the system we have is a CHP ranging from 11 to 74 kilowatt electric output. Or in terms of cows, this enables us to go into farms from 80 up to 400 cows. Gives as well minimal footprint on the farm, mainly being the concrete pad for holding the system. But overall, enables us to go pretty much on every available dairy farms in Europe. Next slide, please. How does it work? So I think you can click to show the animation. So we'll pump several times a day the fresh slurry collected within the sheds into the digester. The slurry will stay within the reactor for around 30 days at 40 degrees to produce the gas, and then the digestate will be stored into the existing storage of the farm, either a slurry store or a lagoon, and then it can be spread onto the land as usual. What we see is the digestate will be a better fertilizer, doubling about the amount of readily available nitrogen. So for the same volume applied, you'll get a better productivity for the crops. Next slide, please. So you can also click. So the biogas produced within the digester will then be sucked by the engine into the container. It will be processed through a gas cooler and a carbon filter to remove the excess sulfur, which can be harmful for the farmer or the engine, and then mixed with air to be combusted. The engine is coupled, belt to a generator producing electricity. And we take the heat from the engine to cool it down to heat the slurry, but also have accessible heat for the farmer to use on the farm. Next slide. The animation. So the electricity and the heat can be used on the farm to offset any usage, and any excess will be exported to the grid. The system will use about 10 to 15% of the production to run itself. And to give you an example, with a 100 cow farm, we're able to run a 22 kilowatt system. So that will produce about 160,000 kilowatt hour a year of electricity and about the same of usable heat. And then can be used on the farm for heating the water for the cows, preheat the robots washings, heat the farmhouse, greenhouses, swimming pool, you name it, really any system will have heat. Next slide. Obviously, to control all of that, we've got an app we design, which is accessible for the farmer, but also the service team, which have the history of the plant from day one in the factory. So we're able to check how the plant is performing, but the farmer can also set his own parameters to better fit the system on the farm. Next slide. How do we work? So as you've seen, we've got a dedicated production line for the AD. We've got nearly 14, 15 years of experience in the system. So we reverse engineer the whole system. So we're fairly competent on the parts we're using. Obviously, the supply chain is really important as well in terms of service. We've got reliable parts in all the different countries. 15% of the company is R&D, so we're ensuring as well we're innovating in the system. As well, you can click, I think there's always, and we Also, obviously, with the 450 plants, we have a lot of data we can get. So we're able to make a lot of computations and assumptions to which part will defect sooner or needs to be replaced before. So as well gives a head on the service. And we also have a 7-day service support on the phone and mostly weekdays on site as the plant is coupled to a maintenance contract. Next slide. So as a case study, just to show you, so a really nice picture. That's one of the newest plant we have in the UK, based in Cumbria, on a family dairy farm. So it's the biggest system we have, 74 kilowatts. In November, it produced 52,000 kilowatt hour. I think this month we're on par to 51,000 kilowatt hours. So it's about a 98-99% efficiency, and the system alone would be sufficient to power about 100 homes in the UK in terms of electrics. We're forecasting nearly 400 tons of reduction of CO2 from the methane. So the system we have reduced the emissions from the slurry management. So not from the enteric emissions, so that's the burps from the cows mainly. So we're looking at the slurry management, so the natural fugitive emissions of the slurry we're getting directly into the reactor. And also the systems as it is now, or AD, on-farm AD, is the best investment per pound available in the UK to reduce emissions compared to solar or wind. Next slide. So at the end, why you were using on-farm AD, as we see rolling in the different countries in Europe. All the farmers have seen the cost rising the past years, especially electricity prices, fertilizer, which doesn't help the business. We're getting pressured by the milk cooperatives or milk players or the supplying chain to reduce their Scope 3 emissions, which they need to do by reducing their emissions on the farms. The system we have is fairly proven now with all the plants running. It's improved the circular economy on the farm, so producing renewables energy, but also better fertilizer for the land. And as said, best pound invested technology available now. So as well, gives some good thinking for the government. So last slide, so 2 QR codes if you want to see. So our website and some testimonies on YouTube of UK farmers. Thank you.
Thank you very much, Joseph. That was really very, very interesting. I think Penny, I think you're coming back to say a few words before we move into the Q&A. Over to you, Penny.
Yes, thank you, Tim. I'll keep this very brief because I want to allow some time for Q&A. So one of the tasks that the Net Zero Methane Hub project has been doing is to look at what the enablers for on-farm methane capture and anaerobic digestion are. So in other words, how do we make this happen more quickly? So if we go on to the next slide, they're summarised here and you'll be able to look in more detail as the slides are circulated afterwards. But what we know from international evidence is that policy support is really important here. So in terms of perhaps grants for setting up the plants or subsidies for the gas produced. The issue in the UK is that the Green Gas Support Scheme only applies where you inject the gas into the gas grid. So small on-farm plant like this are left out. There are some things we could do. So Joseph talked about supply chain investment. We could have tax breaks where, for example, Arla or a dairy processor is investing in the supply chain, or carbon credits are an interesting option that thinking is developing on in terms of a viable market for that. There are a range of technology developments needed. Cost effectiveness of small plant is important here, but there are some key enablers around data. So understanding how to integrate the energy system on the farm, understanding where the methane is if you want to sell that methane off off farm. So think about perhaps a moo map rather than a zap map you might have for your electric vehicle. So there's a range of enablers there, but one of the really gritty problems that farmers are facing, if you go on to the next slide, in the implementation, is the regulatory barriers. So this is about permitting and environmental regulation and planning. Now these are proving to be a barrier in terms of just adding complexity and cost where a farmer wants to install a plant. So you know, if you want to install a plant, you either need to have an exemption or a standard rules permit. And some of these permitting rules are making things difficult for farmers. I won't, this could be a very detailed discussion about it, but I won't start it now. All I can say is that what IFEAA has been doing has been collating some of these barriers and is speaking with stakeholders like Environment Agency to try and make these things easier. So I'll stop there and leave time for Q&A now. Thank you. And I will say that we have 2 events coming up if you want to learn more. One around carbon credits. So we've got some experts speaking around the potential for carbon credits as a way of funding methane emissions reduction activity. And one, if you want to come and learn more about the kit, we're holding an event in Cornwall. Thank you.
Thank you, Penny. And just before we move on to Q&A from the audience, given what you were saying about support from policymakers, I'm very keen to understand, you know, how that has been progressing, because that mapping of the fuel availability relative to, for example, off-grid homes was very compelling, and the calculations you've been doing, you know, in terms of the tier 2 methodology, likewise. Yeah, how much traction is this getting with policymakers in the UK, and what's the kind of way in which these innovations are received?
Yeah, I think what's interesting over the last year has been that I think interest in on-farm projects like this is growing. You know, we've seen much more activities from companies like Bioelectric, Benham and others producing kit. We've seen a lot of events like ours, but also from Royal Agricultural Society to promote the approach. And, you know, there have been from DEFRA, for example, consultations around what should happen with the green gas support scheme when it ends in 2028. So there's potentially room to grow. I think what will be interesting to see is what actually happens in times of support. So is there any changes in the green gas support scheme that are going to help on-farm AD, and can we work with Environment Agency and others to help with some of those regulatory barriers? So if you're optimistic, you would say interest is really growing, and there's, I think, a growing movement. If you're pessimistic, you might say the barriers can be a challenge.
Okay. Well, that's that's a nice sort of balance end to your answer there. Thank you. Let's turn to a few questions from the audience. So if Ed and Joseph could turn their cameras on and join us, and indeed you keep your camera on, Penny, we can have a Q&A session with the audience. So one of the sort of nitty-gritty sort of technical questions, Ed, that it would be useful if you could answer was a lot of dairy farms, the herds are bedded on sand, and does sand entering the manure cause any issues, and what are the solutions that are presented to that?
Short answer, yes, Tim. Yeah, it causes a lot of issues. So ultimately, what we plan with the farmer or the site manager, land manager, is to separate the sand out as much as possible prior to it going into the lagoon. So ultimately, that's sand lanes to allow for gradual filtration and to allow for the settlement of the sand, but also through forms of screening or you know, screw presses and stuff to try and bring the fibrous part and also try and take as much sand out as possible. We have lagoons that operate with sand. We haven't had issues so far. I think the key part is that we have constant management and are motivated to remove it as much as possible. Nothing is a barrier it's about making sure that we've put the right tech in place so that prior to it getting to our lagoon covered area, that the sand is removed. Be the same process for AD, because you don't also want to be degritting tanks with AD. So we want to get it all out as much as possible.
And a kind of follow-on question, really, but from another member of the audience, was: is there any water to be disposed of? And if so, can it be used for land irrigation? Can it be put into watercourses to help support water catchments?
Yes, absolutely. So yeah, on top of our lagoon covers, that because you have, as a lagoon is designed, you have to have an amount of freeboard, as they call it. So 750 millimeters of freeboard. That means our cover sits below the top surface area of the outside wall of the lagoon. So there is an area there that will catch water and collect water. We have built-in sump-controlled pumps. So we've got little water sumps in the corners of the lagoon that can pump out the clean rainwater. That rainwater can be put through a filtration system used back for feeding animals, or it is actually clean enough and recognised by the Environment Agency that it could be used for irrigation, or just even put into a standard watercourse into a ditch. So yes, there is water harvesting, and I think that's a bit that also, I mean, I suppose from our calculations and our financial returns, is how much money do you, or offset cost do you put towards the collection of the rainwater? Because ultimately, at the moment, water is still quite cheap. It's quite accessible. Will it be in our lifetime? Probably not. And farms are being encouraged to, as much as possible, harvest and keep their water. So it can only work, you know, it can only be a benefit, especially if you put it into a reciprocal that means it can be retained clean and used for, you know, for the best purpose possible.
Yeah, no, that's great. And a good comment at the end there about you know, the need to understand the value of these additional benefits in terms of the overall impact of the technology on you know, helping with all our vast range of environmental problems. Joseph, just building on Penny's comment about the challenges of environmental regulation, permitting, etc. What's been Bioelectric's experience of that in setting up in the UK?
I think that's for me. We have, let's say, sort of chance to fall under an exemption paper or permit for the environmental agency regarding the size of the system. So the only issue we'll have is indeed on planning, where either you can go on permitted development, which is a 28-day notice, but the farm needs to be quite isolated or more than 400 away from private housing. When you're closer from that, one we've put in the Wye Valley, it took 18 months to get the planning. And obviously, the plant itself will be 2 months in production to be built and then 4 days to be built on site. So there's a real gap and a real long-term issue or struggle from time to time. And I know now on full planning as well, they increased the biodiversity submission. Which, because we're only using part of the farm which is already maybe concreted or we use as a scrap, I would say, you're not really changing anything on the farmland, but they still want a 10% increase on the biodiversity, which can sometimes create issues because the farmers will just scrape 10 acres of wood just to plant again.
Mm-hmm. Yeah, I mean, that's as we know from lots of other sort of energy components within the industrial sector, you know, planning is a real challenge in the UK. And yeah, so interesting to hear your comments there. Penny, one sort of inevitable question is, what is the balance between enteric emissions and the emissions from farmyard manure slurry stored in open pits?
Yeah. I have been doing a bit of text in the chat about this during the presentations, actually. So it depends partly on what you think the emissions are from slurry lagoons themselves, and then also where you are and what kind of cows you have. So in the UK, if you use inventory values, it's 1 to 10, so 1 manure to 10 enteric. Some of the measurements we have made show that it could be more like 1 to 1, so similar. In California, it's much hotter. the average temperatures are higher overall, and they're looking at more like 2 to 1 manure to enteric emissions. So it kind of depends. And as the chat says, in general, the enteric emissions are lost into the atmosphere. It's very difficult to capture them, but there is some work. Bovar are selling feed additives, which they're saying reduce those emissions by 30%. And then there is some R&D going on to try and capture emissions at low concentrations in barns, but that's at a very early stage at the moment. They're doing some experimental work within universities. Yeah.
Okay. Well, look, thank you. It's coming up for 1 o'clock now, so unfortunately we're going to have to end there. I want to thank all the speakers for participating today, and I also want to offer thanks to John Phillips for liaising with IFEAA to make this event happen, to Noel Hensman and Murat Islam, who've been working tirelessly behind the scenes to support this whole program. And have really make this sort of process industries division community very active. And thank you to you, the audience, for giving up your time during the middle of the day to join us. A reminder that the recording will be posted on the webinar hub of IMechE fairly soon, and the presentation slides will be distributed to attendees at the discretion of the speakers. So have a good afternoon and goodbye.